Your service does the most ordinary thing in the world. It saves a policy to its database, then publishes a policy updated event so everything downstream knows. 2 lines of code. And between those 2 lines, the process can die. The pod gets evicted, the broker is briefly unreachable. The network does what networks do. Now the database says the policy changed and no event was ever published. So every downstream system believes something that stopped being true. Or you publish first, and the database write fails, and now you have told the world about a change that did not happen. There is no ordering of those 2 lines that is safe, and this is the single most common way event-driven systems quietly go wrong. The instinct is to reach for a transaction that covers both, and that instinct is right. It just is not available. Your database has transactions. Your broker has its own idea of durability. There is no transaction that spans a Postgres commit and a Kafka publish, because they are separate systems with separate logs and no shared coordinator. 2-phase commit exists technically, and if you propose it here, someone will explain that it needs a transaction manager, that both participants must support it, and that it introduces a coordinator whose failure blocks everyone. And the second instinct, to retry the publish, does not help either. If the process is gone, so is the code that was going to retry. You cannot solve this by trying harder in the same place. So you stop trying to do 2 writes atomically and do one instead. The trick is almost embarrassing. Write the event into a table in your own database, in the same transaction as the business change. Now the policy update and the intent to publish, either both commit or both do not, because they are the same transaction in one database using the guarantee you already have. Then a separate relay reads that Outbox table and publishes to the broker, marking rows as sent. If the relay crashes, the rows are still there. If the broker is down, the rows are still there. If the whole service dies mid-request, the transaction rolled back and there is no event correctly because there is also no policy change. The relay is deliberately dull. Poll the Outbox for unsent rows, publish them in order, mark them sent. The alternative is change data capture, where you read the database's own replication log instead of polling, which is lower latency and means the application does not even know it is happening, at the cost of running more infrastructure and understanding your database's log format. Either way, look carefully at what you have bought. You have not achieved exactly once. The relay can publish a row and die before marking it sent, and then publish it again. What you have achieved is at least once. The event will definitely arrive, possibly more than once, and that is the whole trade. You converted an impossible problem, atomicity across 2 systems, into an annoying one, duplicates. So which one? Polling is simpler, and you can build it this week with a table and a loop, and its costs are real but boring. A little latency, and a query hitting your database on a schedule forever. Change data capture is the grown-up option, with lower latency and no polling load, and it decouples publishing from your application code entirely. But now you're operating a connector. You care about your database's replication slots, and a subtle version upgrade can ruin a Tuesday. The honest advice is to start with the table. It is the same pattern either way, and the pattern is what matters. If polling load ever becomes your actual problem, you will have earned the right to solve it. And swapping the relay does not change a single consumer. So the event will definitely arrive. It might arrive twice, and we traded that on purpose. Which means every consumer downstream now has a problem it did not ask for. The same message, more than once, and some of those consumers take money. Next episode, idempotency and surviving at least once delivery. See you there.